Okay, so no need to worry. What we are going to do is we are going to talk about those concepts once again, right? So that if you guys have forgot or if you guys haven't revised, everything will be clear now. So before we dance, which topic did we cover? Does anyone remember?
Subnetting.
Right. So we covered subnetting, and that is why I wanted the next topic to be VLANs. Why? Because I'll show you. So we had I took a switch here, right? And along with this switch, there was a router. I'll just use a blackboard here. Choose a different color of pen so that it's more visible. It's clear. So you've got a switch, right? And I was taking an example that there's a company that I want to open up, and there are going to be you know three different departments. And when I purchase the IP addresses from the ISP, this is what I get, right? So this is going to be department one, this is going to be department two, and this is going to be department three. Now, based on what we have covered so far, you guys suggested me that we could go with subnetting. Yes or no? You did, right?
Yes.
Cool. So let's say this one becomes 192.168.1.0/26. This is 192.168.1.64/26. And this one would be 192.168.1.28/26, right? Uh, and we thought that messages would go privately, right? Uh, but that did not happen. That really did not happen. The reason because we bifurcated the network into sub networks. Well, you already know that, and that is why we perform subnetting. But if you try to send out a message, right? For example, this one. So let's consider this subnet, the subnet number one, and I have a message where my source IP is dot one, which is the IP number one or the usable host number one. So this would be dot one. I want to send a message to everyone department one that hey, it's a holiday tomorrow, or hey, it's a holiday today because of Christmas. And by the way, guys, happy Christmas. So then you've got destination IP. Destination IP is dot 63. Can anyone tell me why I'm using dot 63 here? Is dot 63 a usable address or is it something else?
Broadcast address.
Okay, that's the broadcast address. Then obviously I know my MAC address, so could be something, A B C D E F G H. That's my MAC address. Okay, do not worry about it. Just a random value. But then do I know the destination MAC address? Not really. So what am I going to enter it here? I'm going to enter it as FFFFFFF. Okay. What happens? What happens? What do you think, Ram? What do you think, Jayakumar?
It will broadcast, right?
We broadcast it where? Just in the department
No, through the networks.
to the complete network, right? From the switch,
Yes.
right? So this is what is going to happen. So these messages get broadcasted here and here, 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 here. Okay. Well, why does this happen? Because of not because there's a problem with the switch, but because this is how switches work. Okay. So let's talk about the history of switches. So before we had switches, we used to have devices called hubs. Remember? What do these hubs do? Do you guys know? So if suppose this is PC1, well, this is me, and this is PC4, which is Renu. This is Ram, and this is Jayakumar, right? And we want to, I basically want to send a message to Renu, right? what is going to happen in this case?
It doesn't know the MAC address, so it sent to all. Sent to all.
Well, basically, even if it does know about the MAC addresses, this is how it is going to work. It is still going to do what? It is still going to broadcast it. Okay, because Hub is a very dumb device, right? Hub does not care about who the sender is, who the receiver is. Any message that it receives, right? It is just going to broadcast it, right? That is how hubs work. But what was this leading to? Any problems that you can mention? What problems was the hub leading to?
Data collision.
Collision.
Collisions, obviously, because see, if PC2 does not know that PC1 is sending the message, maybe it would try to craft a message for PC3, and what happens? They both, when go to the hub, they're going to collide, and again, data loss, data corruption, right? So this is what used to happen. But then after that, a new device got introduced, bridge, right? So, well, they figured out that collision is a huge problem. So obviously they couldn't eliminate this problem immediately, but they tried to do something, right? So they said that in a network, in a network, if you have, a similar set of devices, make sure that you put those similar set of devices on the other end of the bridge, right? So what I'm trying to say is, if I have this topology, have we discussed the bus topology? We have, right? In our initial classes.
Yes.
Cool. So you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, right? Now, so let's say that 1 belongs to a department called A, 3 belongs to A, 5 belongs to A, 8 belongs to A, and 7 belongs to A, right? Now let's say if one wants to send a message to, the other team members, what is going to happen here? What is going to happen? Basically, others who are not even supposed to receive it, because 2 is a member of department B, right? 9, 10, 6, all these guys are members of department B. So when they have to talk to each other, obviously they'll have to wait. Or if somebody among them sends a message while someone from A is sending a message, collisions are bound to happen, right? So what do they do? In order to reduce the collisions, they are going to segregate the departments through a bridge. So 1, 3, 5, 7, 8. 1, 3, 5, 7, 8. Okay. And then 2, 4, 6, 9, and 10 on the other side of the bridge. Well, at least through the bridge we can ensure that no collisions will happen when the departments are segregated from each other. But collisions will still happen if 1 and 5 generate the message at the same time, right? So the goal of a bridge was to reduce the collisions. So then they came up with a device called switch, right? Switch was working perfectly well, right? There were no problems with the switch. The only problem where it would get stuck, right? Or uh, the weak nerves of a switch get pressed when you send a broadcast message. F F F F F F F F F F F F, right? So if you don't know the receiver's MAC address, obviously this message is going to be a broadcast. But again, it does not send this message again and again. It's only when the receiver's MAC address is unknown, right? So this was seen as a problem, right? Now, how to rectify this? Do we need to create a new set of device again? No, no need to do that. So what they did is they went into the configuration of switches, right? Into the configuration of switches, and basically created a process called VLANs. Okay. Now, what does VLAN do? VLAN is basically going to segregate the LAN into smaller groups, because in the beginning they thought that subnetting is the answer. When you are running a small organization and you can't afford to have, you can't afford to bring in, multiple routers, what you can do is you can basically divide the network. On layer 3 it would work perfectly fine, but on layer 2 there will be a problem. So layer 3 bifurcation is subnetting, whereas layer 2 bifurcation is known as VLANs. Okay. So now when we work with VLANs, we don't have to create something. VLANs are already there inside they're already there inside the switch. We just need to activate it. Right? We just need to activate the VLANs. Okay. Like I told you, they're already there inside the switch. And all the devices that are connected to a switch are basically present in one VLAN. They're all in the same VLAN. That is why whenever we are sending messages, they get broadcasted. Okay. So is it getting clear, guys? Or are you facing any doubts?
Yes, clear.
Okay. So this is the diagram that we drew or we created. This was the logical topology that we created. So you get, this is VLAN 10. I've just named it VLAN 10. You could name it VLAN 1. You could name it VLAN 5. You could name it VLAN 3. Anything that you want, right? And this is VLAN 30, right? The reason why I am using 3 cables, when I'm trying to connect a router to a switch, because each cable represents a VLAN. I mean, I could use one cable, but that's an advanced concept, right? Where I need to teach you the basics of sub interfacing. I'm going to come to that. Don't worry. This is how we are going to proceed step by step. Okay. So this is step number 1. In step number 1, what are we going to do? We are basically going to first subnet the network and then create VLANs out of the network. Okay. So if you don't bifurcate the LAN into VLANs, then on layer 3, you've got subnets, but on layer 2, you'll be in the same broadcast domain, right? And what did I tell you about, the modified description of a LAN? So a LAN is basically one single broadcast domain, right? This is what I told you when we
Yes.
started VLANs, right? So if 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 you're in an interview, right, and the interviewer asks you this question, what is a LAN? Please do not say that a LAN is a set of devices which are connected to each other through, wires or wireless media. Don't say that, right? Because that's not going to leave a good impression. Just say LAN is a single broadcast domain. Well, your answer is going to be impactful, and obviously you'll your answer will, give you an edge over the other applicants for the same job, right? So this is the definition you should be, memorizing, and you should be thinking about, yeah, this one, not the basic one. So when you create VLANs, then what happens is that the broadcast messages stay within that VLAN. They won't go outside. Now, if let's say a device here dot one has to talk to a device here dot 66, You know what is going to happen? Let me tell you. The device sends a message to the switch. The message goes from the switch to the router through this line, the one that connects 192.168.1.0/26 to the router. Then the message is then going to go through the router and then here, okay, then through the switch and then to 66. And this process is known as inter VLAN routing. Got it? I'm going to illustrate this through a lab as well, but is it getting clear? Like, how do different VLANs talk? Yes or no?
Yes.
Okay,
Yeah.
cool. Okay. So what about you, Jay Kumar? Clear?
Okay.
Okay, awesome. So now let's get started. Let's see what we need to do. Okay, so I have so there are some steps that we need to perform or make sure that we have covered these. So configure the correct IP address slash subnet mask on each PC. Yeah, we'll do that. Connect the router one and switch one as explained in the class. Well, how did I explain it to you? How are we supposed to connect the switch and the router? Just through one cable, or are we going to use multiple cables?
Multiple.
Right. So, I mean, just for this lab, we are going to use multiple cables. Then we will move to single cables. Okay. Then we need to configure the VLANs, and then we are going to ping the VLANs and the subnets. So pay attention to this lab, right? Because if I mean, we complete this successfully, the other topics are not going to be that difficult. Okay. Okay. Let's do just one thing. Let's connect. Okay. So what kind of connections are supposed to be there between the switch and the router? Crossover or straight through?
Straight to.
Yeah, straight through. So awesome. So what we are going to do is we're going to take this straight through cable. Okay. I'm going to use G01 where my mouse pointer is, gigabit 01, and connect it to routers G00. Okay, so that's the first connection that I've made. Then I'm going to use G11 and I'm going to connect it to G01. Okay, and then I'm going to use G21 and I'm then going to connect it to G02. Okay, so I made three connections, okay, between the router and the switch. Okay, now before we proceed with the lab, I am just going to write a command here. Show VLAN brief. It tells you about all the VLANs that are there inside this switch. So by default, all the ports of the switch, okay, all the ports of the switch. Now, which ports am I talking about? Let's see. So 1, 2, okay, for PC1 and PC2. Then 3, 4 for PC3 and PC4, which is F51, F61. Okay, then you've got F71, F81. Okay, so there are a lot of ports here, right? And that is how the switches are connected. I mean, that is how the devices are connected to the switch. So all these ports are basically in VLAN 1, okay, including the ones that are connected to that are used to connect the switch to the router. That is why initially we are in the single broadcast domain, okay. And now you would see that there are other VLANs here as well. So you've got 1002, 1003, 4, 5. So basically we don't really use them anymore because uh, so these were used when we used to deal with half duplex mode of communication. Okay, so we leave them as they are. We don't have to do anything with 1002345. I mean, we can't really put a port inside one of these VLANs. Okay, so these are known as default VLANs. So what can we use currently? Currently, we can use any VLAN number or any VLAN ID from 2 to 1001 right now. Okay, we can pick any number because 1002 is taken, 3 is taken, 4 is taken, and 5 is taken. 1 is also taken, and this is the default VLAN. So you can choose anything from 2 to 1001. Okay, so this is known as standard VLAN range. You've got an extended VLAN range as well, but that is something that we are going to discuss tomorrow, not today. Okay, so let's get back. I made the connections. Now let's configure the IP address on each PC. Okay, shouldn't be too difficult. I'm going to go to desktop here, IP configuration, right? All right, 10.0.0.1, and the subnet mask is going to be 255.255. What should be the subnet mask? Which should be the last octet? If it's
0.
20. Okay, take a look at it. It's 26.
192.
Yep, 192. Got it, guys? Everyone? Why it's 192? Because it's /26, which means 2 more ones. Okay, and so if you add 2 ones in the last octet, it's 128 plus 64. So that is why it comes out to be 192. Okay, then let's configure this one. 10.0.0.2, and then it is 255.255.255.192, right? Is there anything else that I need to configure? Not right now. .0.0. What else? This is 65, right? 65. So this will be 10 dot. I'm not going to worry about the default gateway right now. Let's keep it 0.0.0. I'll tell you how are we going to configure it. Okay, 255.255.255.192. Well, this is the step that I don't really like because this is too mechanical, right? And I usually make mistakes whenever I'm configuring the IPs like this. 10.0.0.66. This is the most boring part. .192. Ten dot zero dot zero. What is happening?
129.
They're not even letting me add the IP. What's the problem? Okay, I'll first add a mask here. So this is the PC5 and this is 255.255.192. And when I okay, fine. So I mean, it was throwing an error for no reason. Cool. 129, and then this should be to 10.0.0.0.130, I guess, right? 130. And We are then going to write 255.192. Cool. Okay. Now what have we done so far? We have added the IP addresses.
IP address.
But one thing that we need to make sure is we need to assign the IPs here, right? Because each cable here represents a VLAN. So the portion that I've highlighted basically belongs to VLAN 10. The second one belongs to VLAN 20. The third one belongs to VLAN 30. Okay. So we need to give IP addresses there as well. How do we do that? I'm going to go to the switch here, and as you can see, the router's interfaces as opposed to the switch interfaces, well, the router interfaces are all red. Okay. What does this mean? That all these interfaces are in a mode called shutdown. Okay. So we need to bring them up because for security purposes, a router's interfaces are shut down. They don't keep it up. Okay. What I'm going to do here is I'm going to write en conft interface. Let's go to the one which is connected to VLAN 10 or this one, the first subnet. So I'm going to write int g0/0 IP address 10.0.0. I can write anything, but how do we do it? So whenever we have to give a default gateway. So what is a default gateway? Default gateway is basically the IP, okay, through which a host in your network can go outside its network and talk to other hosts present in other networks. Okay. This is why we use something called a default gateway. Now, why do we have a default gateway? Just take a very simple example. When you have to go, and buy groceries, and currently you're in your house, what is the only way out? Your gate, right? The apartment gate or your home's gate. Similarly, inside a network, you can only go out of your network through the router. Okay. And there will be an interface for that. Okay. So what I just did here is the interface that is connected right here, G0/0. That is the interface which is connected to this particular subnet. So I am configuring it. And are there any rules? Are there basically any rules for configuring the default gateway? Well, not really, because if you look at your own home network, right? How are you able to access the default gateway? By writing 192.168.1.1? Yes or no, guys?
Yes.
Yes.
Right? Either you can use the first usable address or you can use the last usable address, which is 192.168.1.254. Why did I do this? Because, I mean, if you use the first usable address or the last usable address, it becomes easier to figure out. Okay. Because if you use something in between, it will be, more difficult for you to remember in the long run. Okay. So here I already gave the first usable address to this host. So I'm going to give the last usable address to this interface. Okay. So I'm going to go back again. I'm going to write 10.0.0.62. Why am I using 10.0.0.62? Because 64 is the network address of subnet 2. 63 is the broadcast address of subnet 1. Understood?
Yes.
Yeah.
Clear to everyone? I hope there's no doubt.
Yes, no doubt.
Okay, cool. So what am I doing? I am configuring that interface. So I have written IP address space the value of the address, right? And then if I write question mark, I have to provide the subnet mask as well. So 255.255.192. Okay. And then I need to write one more command in order to enable the interface. I'm going to write no shut. And you will see that this interface is now green. Okay. The first interface, the first cable is now green. Well, it's still orange, but it's in the process. Okay, it will turn green in no time. Then let's go to the next one, which is G0 slash, which one is it? Is it G0/1 or which one is it? It's G0/1.
Yes.
So I configured yeah, I configured G0/0. Now let's configure G0/1. So I'm going to exit, then I'm going to write int G0/1 IP address. Now this second interface is basically the one which is connected to subnet 2. So I write IP address 10.0.0. What should I write?
126.
Right? Because 128 is the network address of third subnet, right? And 127 is the broadcast, so 126 is going to be the last usable address. So 255.255.255.192. Okay. Then I'm going to write no shut. Okay, I'm going to write no shut here, and there you go. Okay, it will also turn into green. Then I write int G0/2, right? So IP address 10.0.0. What should I write?
190.
Yes, awesome. This no shut. Okay, this is what I wrote. Sorry. So now I'm going to go back to the PCs. And remember, the default gateway here was 0.0.0.0. I can't let that be. That's a very vague statement. 0.0.0.0 means anything. Okay. So I'm going to configure the default gateway here. And what is going to be my default gateway? The last usable address that I just gave. Okay. Is that clear to all of you? Yes or no?
Yes.
Yes.
Okay. Renu, clear?
Yes.
Okay, awesome. So 10.0.0.62. No, but for this one, the one belonging to the second subnet, I'm going to write 10.0.0.126, right? That is going to be the default gateway, 10.0.0.126. So for this one, it's going to be 10.0.0.190, right? 190. This one as well. And there you go. So up till now, we have completed step 1 and step 2. Now let's go to step 3. Step 3 is going to be very, very easy. Okay. You just need to figure out, all you need to do is to figure out which interface are you going to connect. Okay. So currently there are only 2 devices. So I'm just going to keep F3, F31, F41 and G01. And I'm going to put them into VLAN 10. Got it? Then G11, F51 and F61 into VLAN 20, G21, F81, F71 into VLAN 30. So this is what I'm going to do. So let's start configuring it. So I'm going to go to my switch. en conf t. Now because you have to take what? You have to take 3 interfaces all at once. Because if you take one interface if you take an interface and you do that one by one, it's going to take you a lot of time. So what you can do here is you can write int range. Now, when you do this, when you write int range, it becomes very easy. You do g0/0, f3/1, and f4/1. Okay, why did that happen? Did I make a mistake here? No. Why is it not happening? Interface range not validated. Okay. Why is that the reason? Wait, let me check the mistake that I'm making here. I can actually use commas as well whenever I have to. So int range g0/0. I'm going to write question mark comma f3/1 question mark comma 4,1. Okay, so I'm going to use f4,1. Interface range not validated. Why is that so? g0/0 f3/1 f4/1. I mean, this is how I'm supposed to do it. Okay, does this work? No. Okay, let's first configure this one, then I'll do it. I don't know why this is happening. Maybe something that I'm forgetting for now. Okay, I'll see. Okay. Then I have question mark here. What I'm going to do is I will be writing a command called switch port. Okay. So whenever you are configuring VLANs, all the devices that go into one VLAN, basically these devices are end devices. What are these devices? These are end devices. These are the devices that access the services provided by the switch. Okay. So the port, the name of the port for these devices, okay, or for these interfaces are known as access port. Okay. So an access port is basically something which is there on a switch and helps you connect to the end devices. Is that clear?
Yes.
Okay. So that is the reason why we use this port. So we are going to use access port. So I'm going to write switch port mode access. Switch port access what? What are they trying to access? What are they a part of? What are they part of? So it's VLAN 10. Now this is not an error. It's just telling us that VLAN 10 never existed. The only VLANs that are there, that are already there, are 1, 1002, 1003, 1004, and 1005, right? So they created a VLAN 10 for us now. Okay, switch port mode access, switch port access. What did I write? Switch port access, VLAN
VLAN 10.
10. Okay, and then I'll exit it. I have to put G00 as well. So G00. Okay, so that is the problem. There is no such interface as G00. It's G01. That is the reason. Got it. In G001, switch port mode access switch port access VLAN 10. Okay. Exit. Okay. Then I'll go to switch one. Obviously, there's no other switch. Now I'm going to write int range G1 comma 1. Okay. Yeah, it should be G1 comma 1. F comma F5 comma F5 by 1 and
5,1.
F5 by 1 and F6 by 1. Okay. F6 1. Yeah, there you go. See, it's working fine now. I was worried for a minute, like what is happening here? Okay. So now then I'm going to write switch port mode access switch port access VLAN 20. Okay, so what does it tell us? That there is no such VLAN, so it's going to create one for us. Okay, and then I'm going to go here and we'll start configuring the VLAN 30. So int range G2 comma 1. Okay, sorry, I should go back. Int G2 1 F8 1 F7 1. Okay, and then I write switch port mode access switch port access VLAN 30, right? VLAN 30. So all of this is done. Now what do we need to do? We just need to wait and check the the outcomes of the configurations that we have performed. So I'll write exit exit and we can write show VLAN brief. Okay. If I maximize it, you can see that there's a VLAN 10 inside which there are these interfaces. So now there's a small problem. Why is F41 not showing up here? Right? F41 is not showing up here. F41 is still a part of VLAN 1. Okay, we'll correct that. This is fine, right? G11, 51 and 61 in VLAN 20. And then in VLAN 30, we have 21, 81 and 71. That is also fine. Need to do something related to F41. Okay. So F41 is also a part of VLAN 10. Okay. But labs like these are, these are helpful because see, I made some mistakes. Now I'm troubleshooting that. I realized the mistakes we made. So we can just go back and resolve this. So I'll go into the configuration mode. I write int F41, right? Switch port mode access switch port access VLAN 10. Okay, right? Is that right, everyone?
Yes.
Okay. Now if I go back and run the same command, so everything is running, everything is fine now. See, you've got names for VLAN 1, which is default, then FDDI default for 1002. We can also keep names for VLAN 10, 20, and 30. So let's go to config T and write VLAN 10 name networking, right? That's the name, networking. Right, exit, right, VLAN 20. The name is security. Security, exit, right, VLAN 30. The name is cloud. Okay, exit, exit. And we write show VLAN brief. Everything is now changed. Okay. So currently everything is working fine. all we need to do is open up the simulation mode now. I'm going to open the simulation mode and check what happens when we start pinging the devices. Okay. So let me send a message from 1 to 2. Okay. Let's see what is going to happen here. Is it going to go through the router? See, the reply came back from 2. Okay. And the messages did not go to any other devices. Okay. So let's reset the simulation now. Reset it. And now let's send a message from PC2 to PC3 and let's see what is going to happen now. Goes to the router, then router to switch, and then switch to PC3. PC3 replies back, goes through the router, and through the router, what is it doing? It is going to reply back. Okay, so that was inter-VLAN routing. So did you guys understand?
Yes.
Okay, so when the message is in the same VLAN or in the same subnet, there's no need to go through the router. But if the message is in a different VLAN, a process called inter-VLAN routing starts working. Okay, so that is what just happened. You got any doubts, guys?
Yes, it's clear.
Yeah. Anything that you want me to repeat, or should I start with the next topic now?
Can you repeat one more time, please?
Which one?
The VLAN.
VLANs.
Ah,
Okay. So by default, I mean, we've got a LAN, right? And a LAN is one broadcast domain, right? Which means that if I'm running a small startup and I want to bifurcate my network into smaller networks so that, you know, I need to, if I need to ensure private communication between different departments inside the organization, I can do something at layer 3. But when it comes to layer 2, as soon as a message, which goes from here and is destined for this one, let's suppose this one, the one that I marked, and the switch does not have a MAC address for the receiver, what is it going to do? It is going to label the MAC address as FF, 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 and basically it's going to send it to everyone. Okay, so this is how ARP request works, right? I've already discussed this previously as well. So this is how ARP requests work. Now, what do you do in this case? Because it's a single broadcast domain. So what we have enforced is what is known as layer 3 bifurcation, and it's known as subnetting. So because the layers work in coherence with each other, right? So whatever is done on layer 3 has to be supported by layer 2 as well. Because if that does not happen, nobody will be able to understand, right? So that is why, what are we going to do here, guys? We are going to create
create VLAN.
bifurcation. Yeah, we are going to create bifurcation at layer 2 as well. Okay. And that is going to be known as VLAN. Understood. Now, why do we use VLANs? Because obviously I don't have the money for, expensive routers. I could only afford one so that I could talk to the outer world. But if you're telling me that I should keep three different routers for, three different departments in my organization, I also have to think about the cost, because it's not just about the technical aspects, it's also about the legal and the business aspects, right? The company might not provide you that much budget to, bring in additional routers, because each router costs somewhere around, a minimum. I'm talking about a minimum of 2 lakhs INR to, it can even go up to 1 crore INR. Yes, routers can be that expensive. So that is why. I mean, why waste 6 lakhs when you can just enable something on your switch, right? And that is virtual LANs. Understood?
Yes.
Okay, awesome. So this was a very easy example related to how VLANs work. Now let's, increase the difficulty level. Difficulty level as in this. Now, what if I want to place what if I want to add one more switch? Because obviously switch is, more is way more cheaper than a router. Why am I doing this? Because now my startup expanded a little bit. I used to have only a single floor. Now I've got two floors, right? So one switch for floor one and the other switch for floor two. Okay, but just one router to connect to the internet. Okay. And what am I doing here? Because my networking department increased in size. So what did I do? I made the networking department sit on floor one as well as floor two. So I've got my VLAN 10, half of my VLAN 10 here, and half of my VLAN 10 here. And that is realistic. Okay, you do that. Some of the in the organization, some of the support team guys would, stay on each and every floor. Am I right? That happens, right?
Yes.
Yes.
Okay. So then over here you've got the cloud guys, which is VLAN 30, and over here you've got the security guys, and they belong to VLAN 20. Okay, so this is how it is going. Now, mm, this is representing, this one dot represents VLAN 10, two dots represent VLAN 20, three represent VLAN 30, right? And then because I haven't taught you any such mechanism between, any such mechanism on the switches as well. So what I'm going to do here is I'm going to keep this for VLAN 10, this for VLAN 20, this for VLAN 30. Now you might be thinking this is absurd, but there's a reason behind, why I'm doing all this. Okay, there's a reason behind why am I doing all this. So that is why I'm using different cables. And just like you guys, I also think this is absurd, because what if you have 100 VLANs? Are you going to use 100 cables? No, right?
Yes.
Okay, definitely not. Although this makes it very easier. Okay, that all the VLAN 10 messages will go through this cable, all the VLAN 20 messages will go through this cable, all the VLAN 30 messages will go through this cable. It's also easier on the router. But what is it adding up to? I mean, what is it trying to increase? It is increasing the cost for cables. Also, because now there are a lot of cables and wires, so troubleshooting is going to be a big hassle. Figuring out what went wrong and where it went wrong, that's going to be an issue, right? So number one is cost, number two is troubleshooting or localizing the fault. That's going to be very difficult now. Okay, so what we are going to do, the first concept of today, I mean for today, pertaining to this set of labs is going to be trunking. Okay, any idea what trunking is?
It allows a different VLAN in the single cable.
Right. So obviously, if we have a lesser number of VLANs, like just two or three, then there's not going to be any problem at all if we are using individual cables for every VLAN. Okay, that's fine. But what if the VLANs increase? Because how many VLANs can we create in total? We can create in total 4096 VLANs. I told you that we could create anything from 2 to 1001, but those are standard VLANs. Okay, we also work with something which is known as extended VLANs. Extended VLANs. We can also create extended VLANs. Okay. So what do we do in that case? Obviously, we'll have to think about something now. We can't use 4096 cables. That's going to be really expensive, and also we don't even have that many ports inside our switch, right? We don't have that many ports inside our switch or our router, right? So here we are going to come up with a concept called trunking. What is trunking? So basically trunking lets you carry traffic from multiple VLANs into a single cable. That is what Renu just said, right? And that's the that's absolutely right. So what does trunking do? What is trunking? Trunking basically lets you carry traffic from multiple VLANs, no matter how many there are. How many they are? I mean, could be 10, could be 20, could be 30, could be any number of VLANs up till 4096. You can carry the traffic into a single cable. Okay. But the thing is, how do you differentiate? How do you differentiate? You differentiate that through something which is known as labels. Okay. For each frame, because whatever we are doing right now is on layer 2. So layer 2 is going to work with frames, right? We studied this in the USI model. Yes or no?
Yes.
Yes.
Right. So we are going to label our frames, or we are going to tag our frames. So this is the technical term that we use. We tag our frames. Okay. We tag our frames with the VLAN number. Okay. So now instead of this, now we can straight away use one connection between the switch. This is going to be VLAN 10. This is going to be VLAN 30. This is going to be VLAN 10. This is going to be VLAN 20. And even for our router, we are going to use just one cable. I'll show you how to do it. Okay. So these are trunked ports. Okay. The ports between the switches. Okay. The ports between the switches are known as trunked ports. Why? Because there's just one interface, and one interface is going to carry traffic for VLAN 10, VLAN 20, and VLAN 30. Okay. These are known as trunked ports. And obviously the ones that are connected to end devices are access ports. Got it? Yes or no?
Yes, yes.
Okay. So for trunking and tagging the frames, we use some protocols. There are standards for doing that. We can't just do it in a way that we like, because the way that we like it's possible that it could be difficult to understand for some other people, right? So we have standard protocols for that. One of that is obviously something from the IEEE 802 project, and it is 802.1q, also known as .1q. Okay, .1q. That is one protocol. The other one is ISL, Inter-Switch Link by Cisco. Okay. Now, again, this one can only be applied to Cisco devices. This one is used worldwide because there are different vendors as well. Juniper, Cisco, Huawei, Nokia, multiple devices are there, right? Multiple vendors are there. So we are going to work with this one. Okay. And this is something that we'll be discussing tomorrow. Okay. Sounds good?
Okay.
Okay.